Okay, we're going to do practice D. (3D), and there are 5 problems. And these are projectiles launched horizontally. Okay, so let's just start with number 1. We're going to write our given, and we're going to write our find. And it helps in these types of problems to also kind of draw a picture to help us conceptualize. So it says a stone is thrown horizontally at 8 meters per second from a cliff 78.4 meters high. So again, I already read a lot of information and I want to chunk. So when we do projectile motion, we write our X and Y separately. The first thing that we're going to write on every problem is the horizontal acceleration is 0 and the gravity is negative 9.8 meters per second squared. When I look at my little picture, here's my cliff. Here is my object, the stone. Where motion begins is my frame of reference. Okay, so this is like the coordinates of a graph. The stone is thrown horizontally. So this vector represents the velocity, which they said VI is equal to 8 meters per second on this cliff. Now the cliff, they told me the cliff is 78.4 meters high. So this is my frame of reference. So because I'm measuring from here down, you see how that's pointing down? In my given, I'm going to write that y is equal to negative 78.4 meters. Now this projectile is going to end up going like this. Also in my given, I want to write down the horizontal and vertical components of my initial velocity. Now this is all horizontal. It has no vertical components. So Vix is equal to 8 and Viy is equal to 0 because this is all horizontal and it has no vertical component. Where do I start? Well, I haven't looked at what they said how far from the base of the cliff where the stones strike the ground. So I want to find X. So that's what I need to find. What should I do? Well, let's say I don't know what to do. When you don't know what to do, you go to the end. So going to the end means, what am I solving for? I'm solving for X. So X is equal to Vixt plus 1/2 AXT squared. Now, we know that there's never any horizontal acceleration. So this whole last term goes to 0. And it always is that way when we're talking about horizontal. With projectiles, the horizontal component. Now, I know sometimes people will tell you, oh, here's a new equation for projectile motion. It's the same equation. The horizontal acceleration is 0. Now, when I look at this, I have Vix. I want to find this, but I don't know time. So even though I'm not able to solve this now, it tells me the next step. This is my systematic approach to problem solving. It tells me, okay, if you find the time, then you go back and substitute in here. Well, how do we find the time? Well, I look at my givens and finds. All my equations have 4 variables. So I'm going to say, well, which side has 3 so then I can find the 4th. So I see here I have 3 variables. So what are my variables? Well, I have G, I have VIY, I have Y, and I want to find T. So now I'm going to say to myself, which equation has those 4 variables? So the equation that I'm going to use is y is equal to VIYT plus 1/2 GT squared. Now VIY is 0, so this whole term goes to 0. So now I have y is equal to 1/2 GT squared. Now I'm not going to just substitute in my values. I'm going to rearrange the equation to solve for the unknown in terms of the known, and then substitute and solve. I'm going to carry my units through and cancel them in order to check my work. So what I'm going to do is I'm going to multiply both sides by 2y. Then I'm going to divide by g. So 2y over g is equal to t squared. And then I'll take the square root of both sides. So t is equal to the square root of 2y over g. I'm going to substitute in my values. 2 times negative 78.4 divided by negative 9.8 meters per second squared. Now, do you see the numerator and the denominator both have a negative? So they're going to cancel, so I end up with no negative under the radical, because I should not have a negative under the radical. Now, when I do all this math-wise, remember, I'm going to end up getting about 4 seconds. But I want to make sure I didn't make a mistake. And in physics, we have a foolproof way to check our work every time. So I'm not just going to throw that second in on the end. I'm going to look at my units. So underneath the radical, I have a meter divided by a meter per second squared. A meter divided by a meter per second squared, which is the same thing. So remember, when I divide by a fraction, it's like multiplying times the reciprocal. So I'm going to have a meter times a second squared over a meter. So this meter cancels with that. So I have second squared under the radical. So when I take a square root of the number, I also take the square root of the unit, which ends up being seconds, which is the correct unit for time. So now I know I did not make a mistake. Going back to the original problem, I want to find x. So x is equal to VIX times t, which is going to be 8 meters per second. And remember, the time is the same, x and y. So if I get the time is equal to 4 seconds on this side, the time is also equal to 4 seconds on this side. So now I'm going to substitute in my values. And 8 times 4 is equal to 32 meters. And that's it. So again, when doing this, your horizontal and vertical motions are independent of one another. I'm going to write my givens with 2 columns. I'm going to draw a picture to help me conceptualize, and I didn't put, again, that this was y. I'm going to be consistent with my sign convention. I'm going to rearrange my equation to solve for my unknown in terms of my known before I substitute and solve. And again, the problem is going to solve itself, because when you write what you're given and what you want to find, you'll easily be able to know which equation you want to use to solve the problem. That's it.